In this video, we will discuss about the family of curves. That means orthogonality of the system. So now we have one theorem based on this. theorem का statement we write down as if fz is equal to u plus iota v be a analytic function so then prove that the family of curves u is equal to c1 and v is equal to c2 forms an orthogonal system. Forms an orthogonal system. अब orthogonal systems means make the right angles. तो family of curves. Suppose ये कोई भी curves है, इस form में curves दे रखी है and which makes a orthogonal system. That means make a right angle. Right angle for condition of orthogonality, we know that already. So now we shall prove this theorem as, so we write down as since fz is an analytic function. Fz is an analytic function. So then the CR conditions for fz, so we write down as del u upon del x is equal to del v upon del y, and del u upon del y is equal to minus del v upon del x. So these are the CR condition when function fz is analytic. Now we move to the curves. So given that u is equal to c1, u equal to c1 be the curve, so u equal to c1, so then the total derivative, इसका total derivative क्या होगा, du is equal to 0. So when du equal to 0, so now when u is function of xy, अब आपने total differentiation पढ़ाई होगा कि u is function of xy. When u is function of xy, so then we obtain the total derivative of this du. So we write down as del u upon del x into dx plus del u upon del y into dy. So now here we write down the same as, so du, so we write down as du equal to del u upon del x. तो यहाँ पर टोटल डिफरेंशियल यूज कर रहे हैं और इनटू dx और प्लस del u अपॉन del y इंटू dy. और du क्या है, du इक्वल टू 0 है. तो when du इक्वल टू 0, so this we can write down as del u upon del x into dx और प्लस del u upon del y into dy is equal to 0. So this we can write down as del u upon del x into dx is equal to minus del u upon del y into dy. अब व्हाट इज द वैल्यू ऑफ dy अपॉन dx, तो यहाँ से हम वैल्यू कैलकुलेट कर लेंगे dy अपॉन dx की. तो dy अपॉन dx जाएगा, तो दिस वैल्यू कैन बी रिटन एज del u अपॉन del x अपॉन del u अपॉन del y. So this is the equation number 2. So this is the value of dy by dx. Now similarly, again, given that v is equal to c2, so v equal to c2, so when we take the total derivative of this, so this gives us dv equal to 0. So now we write down the total derivative of this as del v upon del x into dx plus del v upon del y into dy is equal to 0. So here we calculate the value of dy by dx. So del v upon del x into dx is equal to minus del v upon del y into dy. So this implies that dy upon dx is equal to minus del v upon del x upon del v upon del y. So this is the equation number 3. So this is the equation number 3. Now, अब कंडीशन ऑफ ऑर्थोगोनलिटी क्या होती है? कोई भी कर्व जब किसी दूसरी कर्व को काटेगी तो किस पे काटेगी? वो मेक राइट एंगल। तो कंडीशन ऑफ ऑर्थोगोनलिटी क्या होती है कि m1 इंटू m2 इज इक्वल टू -1। तो कंडीशन ऑफ ऑर्थोगोनलिटी, अब m1 m2 क्या है कि m1 m2 इज द स्लोप। अब स्लोप जो फर्स्ट है dy अपॉन dx, इसको हम रिप्रेजेंट करेंगे किससे? m1 से। और ये dy अपॉन dx सेकंड वन, दिस वी कैन रिप्लेस एज m2। सो m1 dy अपॉन dx स्लोप, so dy upon dx we write down as m, that is slope. So we replace dy upon dx as m1, that means first curve, or second curve we replace as m2. So now from 2 and 3, so we write down as m1 into m2, m1 into m2. So this we can write down as m1. m1 is del u upon del x upon del u upon del y. So m1 means first the equation number 2. Del u upon del x upon del u upon del y. So here we have the negative sign. Now, similarly, we write down for del v upon del x upon del v upon del y. So this minus to minus cancelled. So now we write down this as del u upon del x upon del u upon del y, and we apply the CR condition. So using 1, del v upon del x we can write down as del u upon del y. So here we have CR condition, del v upon del x, so minus del u upon del y. So this we can write down as minus del u upon del y, or del v upon del y equal to del u upon del x. So this del v upon del y to this cancel, this to this cancel, this gives us -1. So this is satisfy the condition of orthogonality. So m1 m2 equal to -1. So hence the family of curves are orthogonal. So we have proved this theorem.